Today we are going to do section 7.8, the determinant and the Cramer, more importantly, the Cramer's rule. But first we have to, the determinant of a 2 by 2 matrix, such as we call it A, is equal to A times D minus C times B, doing the X action. We have seen something like this before in some formula, but that doesn't, we didn't call it determinant that back then. We call this thing the determinant now. Okay, so determinant, you have to memorize this. The determinant of a square matrix, 2 by 2 square matrix, is AD minus CB. Is just something that you have to cram in. Okay, so let's look at example 1. Okay, turn to the next page. We have some random 2 by 2 matrix, 5, 2 minus 6, 3. What is the determinant? Determinant is 5 times 3 minus negative 6 times 2. So 5 times 3 is 15 minus negative 12, that's 15 plus 12, that's 27. See, that is a very quick way of getting this to come out. So next thing we're going to do is we're going to prove Cramer's rule. Okay, we don't do that much proving in here most of the time, but this time we're actually going to prove it. So let me write this down. So right now we have a system of equations with two variables, x and y, and they're being multiplied by numbers called a1, b1, c1, and a2, b2, c2. Now this might look like a lot of variables to you, but you can imagine a sample here. I have a sample right here for you to visualize. For example, you can pretend a1 is 5, okay, b1 is minus 4, and c1 equals to 1, etc. So all the ABCs, whether they are 1 or 2, represent numbers, whereas x and y are the variables. The fact the A1 just means that they're the coefficient of x, and all the B's means they're the coefficient of y. And C is the coefficient of nothing. Okay, C is all the numbers on this side. So the ones and twos, that it doesn't mean that the C's are related in any way directly. It just means they are the same type of thing. That is, the A's are all the coefficients of the X's, and the C's are all the constants, that sort of thing. So with that, you can fancy, or you can even make up your own sample. It doesn't matter. The point is the ABCs are the numbers, and then X, Y are the variable. And we're trying to solve an equation of this type. And how will we solve it? Now, with the old tricks that we've learned in the past, what we will do, one way we can do is multiply this. We'll call it equation 1, okay? This will be the equation 2. To solve this thing, we're going to multiply equation 1 by B2, sorry, okay? According to your book. This is on page 778. So let's multiply equation 1. We'll multiply equation 1 multiplied specifically by B2. Now, in this case, B2 happens to be 8 in my sample, but that means nothing, okay? Whatever it is, we're multiplying by it. And remember, B2 together is one number. It's just the second B or something like that. Anyway, so let's multiply equation 1 by B2. That will give us A1 B2 X plus B1 B2 Y. I'm just multiplying everything by B2, okay? If you multiply by B2, not knowing what anything is, that's how it's going to be. So, and then that equals to C1 and B2. All right, and then it says that we need to multiply equation 2 by minus B1. All right, equation 2 shall be multiplied by negative B1. Okay, so let's do that. Equation 2, that thing, multiply it by negative B1 across the board. So we have A2 times minus B1 and okay, then there's X, okay? We're multiplying this thing by negative B1, okay, right there. And next, plus B2 times minus B1. We're still doing the multiplying the B1 business, okay? And then lastly, C2 is also being multiplied by minus B1. Everybody is being multiplied by minus B1 across the board. Okay, so at this point, what we're going to do is we're going to add these two equations together. Now, what happens when we add them together? You notice this is B1 times B2 plus B1, B2y. This is negative B1, B2y. Okay, so these two terms, when we add the two equations together, these two terms will cancel each other out. So all we have is these things and the things at the end. These things will kill themselves. Well, they will kill each other, let's say. So what we have left is the A1, B2, and this one becomes a minus, okay, A2 minus B1. So this is minus A2 B1. And both of these will be multiplied by x. So I'll write the x outside. It corresponds to multiplied to each one. And then all the y's have killed themselves, killed each other. So we have left on this side is C1 B2 minus C2 B1. All right. So then from this equation, then these are just numbers, okay? The C's and B's, you can imagine the numbers that will multiply together over there. And so are these. These are numbers being multiplied and then subtracted. So x, we can solve for x in this case. X then is equal to this A1, B2 minus A2, B1. And then on top, we'll have C1, B2 minus C2, B1. See? So that's the equation for x. And that is Cramer's rule. Cramer's rule says that to solve for x, you just do this. You take C1, okay, times the B2 minus C2 times B1, and divide the whole thing by A1 times B2 minus A2 times B1. Okay, this is the Cramer's rule, which will come in very handy. Cramer's rule seems to be used quite often in the future. So it's extremely important to learn it. But there isn't really much to it. This is it. Okay, this is the entire Cramer's rule. So next, we have solved for y. We have solved for x. Now, what about y? We'll solve for y in exactly the same way. So at the bottom, towards the bottom of the page, we're solving for y by doing a very similar thing. Okay, we'll solve for y by multiplying the row 1. We'll multiply equation 1 by A2 times A2. So let's do that. Okay, equation 1 by A2 gets us right here, times A2, the whole thing. So we have A1, which is the old one, A2x, all right, plus A1, B1, y. A2, right? Yeah, we're multiplying by A2. And then that equals to C1, what am I doing? The 1 is too big. The 1 needs to be on the bottom. It's called a subscript. All right, so C1, where's C1? C1 times A2. We're still multiplying by A2. Okay, so that's equation 1. And then equation 2, we need to multiply equation 2 by the negative something, A1. Multiplied it by minus A1. All right, so this one must be multiplied by minus A1. Let's do that. So minus A1, A2, x, and then plus minus, okay, minus A1. So minus A1, B2, y, and then equals to minus A1, C2, right? Everything multiplied by A1. Okay, again, we are going to add these two things together. And as you notice right here, there's an A1, A2x here, and there's a minus A1, A2x here. So these two things will kill each other, okay? And then, right, just like over there. And so we have just this thing left. I think I'll stand over here. So we have, let's add this stuff up. So this disappears. We have just this part left. And so we have A2 B1 y minus A1 B2 y, and that equals to C1 A2 minus A1 C2. You notice there's a pattern of the numbers going back and forth, okay? A21, and then A1 B2 and C1 A2 and A1 C2 and all that stuff. So the Cramer's rule is really symmetrical that way, and that part is pretty nice. So as a result, following this, we'll get something similar to that for y, except that, so y equal to this stuff, and we'll write down A2 B1 minus A1 B2. Notice that that's the same thing down as the denominator here. They have the same denominator, but the numerator will be the same. This will be look different. C1 A2 minus A1 C2. So that the stuff has C's on the top, but for X there's the B's, and then for Y there's the A's. Otherwise, the pattern follows. See, there's a B2 and A2, and then there's B1 and A1. So that is so that's the Cramer solution for y. And because the reason they're the same is because they start out looking the same. Okay, so then the answer is also looking very similar. Anyway, so that is our good old Cramer's rule for solving 2x2 equations. To solve it, then we just do all these multiplication and stuff and not mess up. Then we get the answer right away. So let's look at the next page. Okay, so there is some things to be said about this. First, this thing right here is the determinant. Okay, as we mentioned before, if we write down the matrix for this thing, for this equation, the matrix would be A1, B1, A2, B2. Okay, so then the determinant, as we mentioned, it goes down this way, is A1, B2 minus A2, B1. So this thing is the same as the determinant. Okay, so that we can say that this is just the determinant. But what about that thing? That thing is similar to the determinant, except that the A1, the B1 and B2 got replaced by C1 and C2. So that is called, let's see, determinant. Okay, so let's look at page 779. On page 779, we have these things. Okay, this is also called, let's see, the top part is called dx, and the bottom, the denominator is called d. Okay, this is called dy, and the denominator is called d. The reason is because dx is equal to, here's the definition for dx on the same page. You notice dx is the C1, B1, and C2, B2 thing, whereas dy is A1, A2, and C1, C2. Yeah, so that is because that end up being just this thing. Okay, if you calculate what dx is, that's dx, for example, is C1, B2. I'll make it bigger. There, C1, B2 minus C2, B1. See, just like it says. So you can write it this way as the determinant. Similarly, the dy is, let's see, is why is my determinant different? A1, C2, the minus is wrong. Let me check to see if I wrote something wrong. Oh, I see what is happening. See, this is A2, B1 minus A1, B2. This is A1, B2 minus A2, B1. I need to turn both things around, okay, like this. So this is the same as, if you turn both things around, that this is the same as A1, C2 minus C1, A2. That is, we'll slap a negative sign on both of them so that we can turn them around so things look right. Okay, let's slap a negative sign on both. That way nothing's different. And but except that we'll turn everything around. That will be A1, B2 minus A2, B1. All right, so that will look somewhat better. As a result, as I was saying before, okay, dx equals to a1c2 minus a2c1. See, it just can you see that? Okay, and yeah, a1c2 minus a2c1. You do that thing there. Draw the x. So that is exactly what that is. Now, so remember that the way to calculate. So basically what happens is this, okay? To follow Cramer's rule, now listen to this very carefully. To follow Cramer's rule, what happens is that you put a determinant on the bottom, okay? That's the determinant. And then on top, to calculate x, okay, you replace C1 with a you replace C1 onto the coefficient of x. See, it used to be A here, right? You put C here. If you put C here, you're calculating x. If you put C on the other side over B, if C replaces the B's, that is y's coefficient, then you calculate y, and that's how you remember these two formulas, and they're very important. So it's critical that you memorize these two things. And right now, they're basically you're just calculating. In other words, when you solve a 2x2 two equation, two unknown thing, you just have to write down the determinant on the bottom of this is a division happening. Okay, this is that divided by that, which is what we have here. So then when you're doing the division, replace the last row right here. Okay, whatever it equals to, replace these numbers, slap it on top of the x coefficients if you are calculating x, or y coefficients if you are calculating y. That's how these formulas are memorized, by me anyway. So that is, generally speaking, Cramer's rule. So let's then do an example of that. Let's look at example 2 on the bottom of this page. After I erase the board, maybe? No, I have a little bit of space here. So let's continue here. Okay, so we have a fairly quick problem. What are we doing here? We are solving this, okay, solving for x and y. So we have a fairly simple problem, and let's do exactly what it says. So what's x? X will be equal to the determinant, which is just the determinant is just these numbers written down. That is, the determinant is 12, 3, 2, minus 3. Okay, 12, 3, 2, minus 3. That is the determinant of all the coefficients. So I have 12, 3, 2, minus 3. Does that look right to you? Yeah, it looks okay to me. Okay, and then to calculate x, we will write the same thing, except that we'll slap the 15 and 13 on the x position. See, these are the coefficients of x, so we'll replace it with 15 and 13. Those are the numbers on the other side, but we'll keep the original y values. That's it. Okay, that's the value of x, and now we just have to actually crank that out. Like, what is that? Now, to calculate it, I need my calculator, which I'm not seeing right now. Let me find it. Okay, so let's crank that thing out. What are we cranking? First we will turn this thing on. Okay, we will first use parentheses because we have some subtraction subtraction happening, so we need parentheses. So first we'll do that cross business. Okay, so we'll do 15 times minus 3, 15 times negative 3, okay, subtracted by 13 times 3 times 3. Okay, this whole thing will be divided by what's on the bottom. What's on the bottom is 12 times negative 3 minus 2 times 3, which is 6. All right, 2 times 3. Okay, so that should give us something. So x equal to 2 according to this calculator, if I didn't punch anything wrong. So let me look at the answer here. What does it say? Yep, it is 2. So that's x. Now y will be done similarly, except the only difference is for y, the numerator will keep x, and the 15 the 15 and 13 thing will go over the y position. So 15 and 13 go on this side. And x will stay this way. That will be 12 and 2. And the denominator will be the same. Okay, so this thing will go over there, same way. So let's calculate that on the calculator. Well, anyway, right, I'm just gonna edit the first part maybe. Nah, let's not edit anything. Okay, so again, parentheses, very important. 12 times 13, 13 minus 2 times 15, which is just 30. And then close parentheses, okay, that's everything on top, divided by that same thing. 12 times negative 3 minus 6. 2 times 3 is 6. All right. I got minus 3. So let's see if that's right. Okay, let's turn to the following page. Yep, minus 3 is correct. So that is that. And with that, I will erase the board. Next, let's go to page 780, where we look at some 3 by 3 matrix. Okay, the determinant, we're going to calculate the determinant of the 3 by 3 matrix. Now which means we have A1, A2, A3. Now that look like a lot of symbols. So imagine A1 is say 1, A2 is 0, and A3 is minus 3, etc. Okay, they're just numbers. Each one is C. The letter C and the letter 1 together means it represents one number, some number. We don't know. You can make one up yourself. Okay, I made one up right here as a sample, so that you can tell your brain that these are just numbers. Each one is a number, and together there's 9 of them, and make a 3 by 3 matrix. All right, so we are going to calculate the determinant of this thing. And the determinant will be calculated like this, okay? Look at about the middle of your book, where there's this picture right here, which I have blown up. And the determinant shall be calculated first going down. A1 will be multiplied by B2 and then multiplied by C3. Next, B1 will multiply by C2, then multiply by A3. Now, I should mention that first what you do is, this is the matrix itself, and then you repeat the A row and the B row are next to it, like this, okay? And before you can do this process. Once you've done that, then you can do this neat little process, which is follow the orange lines, okay? You multiply A1, B2, and C3 together. Do the same thing with B1, C2, A3, and you add it together, okay? Add the products, like it says on the bottom. A little bit, you see, we have, it says A1, B2, C3, and multiplied together, need to be added by the next pack, which is B1, C2, A3. You need to add those together. And the last thing you need to add is C1, A2, B3. Everything is written in order, right? You just go down the diagonal, and so you have 3 things being added together, like this. See, so far so good. But and then the next thing you're gonna do is you're gonna go up. Now the determinant, we have to do that cross thing, right? You go down and then you cross back up. Well, that is exactly what you're gonna do here. Next, you will multiply A3, B2, C1. But this time you are gonna subtract, okay? All the blue things are subtracted. Next, you go to B3, C2, A1. Next, you go to C3, A2, B1. Now you can't come to the end. You can't move any farther and still have 3 things to multiply. So that's it. So you multiply 3 things down, okay, starting from the first one, and then 3 things back up. Again, starting from the first one, except that the things that goes up all has to be in minus, like they show here. See, the minus situation is happening. So all the ones going up will be subtracted, and all the ones going down will be added. And after you do that, so you multiply a bunch of, you have 6 packs of numbers multiplied together. Okay, 3 of them, 3 packs added together and 3 packs subtracted together. And when you're done with all that, then you have calculated the determinant. So let's try doing that, pulling that trick. Okay, here's example 3 at the bottom of the page, which I will copy down. So I have it written down here, okay? The original determinant 0, 2, 1, 3 minus 1, 1, 4, 0, 1, and we repeat the first and the second row. So there's 3, 0, 3, 4, and then 2 minus 1, 0 is being repeated. And then we're going to do that trick of multiplying down, okay? And then subtract it by the multiplying up diagonally. So let's do that on the good old calculator. Okay, so to do that, I guess I will stand, excuse me. I will stand here. Let me turn on my calculator again. And so going down, that is minus 1, right? The first one seems to be minus 1. I'll write that down. And minus 1 plus, the second one is 8, right? 2 times 4 is 8. Plus 8, and then the third one is well, wait, what did I say? This is multiplying. Let me try again. Sorry, 0 minus 1. If there's a 0 there, the whole thing is 0. We're multiplying, right? What am I thinking? So this is 0. So the second one is 8. Okay, so I write down 8, and then the third one is also 0, right? Because if there's a 0 in there, the whole thing is 0. So all 3 diagonals only got us 8 so far. Then the next step we're going to do is minus. Minus going back up. 4 minus 1, 1, that's negative 4. So minus negative 4. Okay, I have it right here, minus negative 4. That's the first row going up. Second row going up has a 0 in it, so we don't have to pay attention to it. It's 0. Third row going up is 6. So we need to do minus 6. Okay, so I have that. And let's push the equal sign and see if we get anything. I got answer 6. Let's see what the book says. The book says 6. So we're right. So that isn't so bad. But that's because we have certain zeros in here. And 0 do make it somewhat easier. Let's see. So next. Let me see what we're going to do next. So next, let's look at page 781 towards the middle, where we have the Cramer's rule for 3 by 3 equations. They will be identical to the Cramer's rule of 2 by 2. Now, the determinant is what we just learned, okay? It goes you write down basically the matrix identically to the system of equations. All the coefficients are written down here as a matrix, and that's called a D. And calculating its determinant, it will be called D. Now, dx means the last row has to replace the location of the coefficient of x. So A is the coefficient of x, so the D's will replace a location, okay? And that will be dx. Oops, sorry. So when you calculate the determinant, then you will if you calculate the determinant of both and do the division, then that will give you the value of x. And y and z it works in a similar way. For example, to calculate the dy, then you put the d's, okay, in the position of the coefficient of y. The coefficients of y are b, right? Why is this thing moving? Here. Okay, the coefficients of y are in the b position. That is, they're in the middle. So you slap the d's on top of over the b's. Okay, so they kick the b's out and put the d's there. That will give you the dy, and eventually dy divided by d will give you y. And similar for z. For z, you have you will use the d's and put it on top of z's coefficient, which is c. All the c's are being replaced by the d's. That will give you dz, and then dz divided by d right here will give you the answer to z. And that in a similar way to the 2 by 2 coefficients. 2 by 2 matrices. So this is Cramer's rule for 3 variables and 3 unknowns. In other words, anytime if you want to solve a 3 by 3 system using Cramer's rule, then you just have to calculate these 4 determinants. And once you have done that, then you are good to go. Okay, so that is I suppose that's what we're about to do. Okay, let's look at example 4, which we have a 3 by 3 system. And we are supposed to calculate. So here's the system, okay, and I will write down its matrix, the determinant. So now let's look at example 4 on page 781. We have D equals to all that, okay, assuming I got it right. 1, 1 minus 1, 3 minus 2 and 1, and then 1, 3 and minus 2. It looks okay to me. That's just the coefficient matrix of the system of equations. I wrote down row 1 here, repeated row 1 and row 2 here. I think I did okay. And then so that we can calculate the determinant of this thing. What is D? And so we're going to first go down, okay, go down 3 times, and then go back, subtract going up 3 times. So let's do that. I will stand over here. So going down, we have 1 times minus 2 times minus 2, that's 4. And then plus next, 1 times 1 times 1, that's 1. Next, minus 1 times 3, that's minus 9. Negative 9. Okay, and that's the first 3. And then going back up, subtracting, we'll subtract. The first one going up is 1 times minus 2 times minus 1. That is, should be 2. Okay, next, 3 times 1 times 1, that's 3. Next, minus 2 times 3 times 1, that's negative 6. So type in negative 6. Okay, yeah, remember to type in minus negative 6, because that'll turn it into a plus. So I got negative 3. Let me see if I got it right. Where's the determinant for this thing? I think, oh no, I lost the page again. Okay, I got it. Okay, next page. What's D? D is, what did I say it was? Negative 3. Yeah, apparently it is negative 3. So we're doing so far so good. D then equals to negative 3 minus 3. All right. So next we are going to calculate dx. Okay, and what is dx? Dx is the same matrix, except that we're going to replace, what was the last row of stuff? Let me see. Go to the, okay, the last row of things is 6 minus 15 and 14. And that will, to calculate x, we'll replace it by the x coefficients. So let me write that down. So I have 6 minus 5 and 14. That is the last row of numbers. The numbers on the end here. Okay, replacing the first row, because first row is the coefficients for x. See, the 1, 3, and 1. So I slap this right over there, but the rest is the same. Okay, except this part. This part I have to repeat this row, and then this row. So this thing has the new numbers on it, but this has the same old numbers. So now that we have that, let's crank out the determinant, just like we did before. Okay, we'll go down diagonally 3 times, and then, which means we reach the end. And then we'll go back up, subtracting, going back 3 times. So let's do that. All right, first I clear the old screen. So going down, 6 times minus 2 times minus 2, that's positive, 24. Okay, next going down, that is plus 14. Next, going down, minus 1, minus 5, 3, that's positive 15. Okay, that's all the plus. Now doing minus, going back up, 14 minus 2 and minus 1. That is positive 28. So 28 minus, next, 3, 1, 6, right? 3, 1, 6 is 18, so 18. And then minus 2, minus 5, 1. Minus 2 minus 5 is 10, so 10. Okay, so I got negative 3. So I got dx equals to negative 3, which is the same thing. Now, let me check to see if I got it right. Dx is negative 3, so I did get that right. So dx equals to minus 3, which means x then equal to the dx over d, see? So it's minus 3 divided by minus 3, which is equal to 1. So x is 1 so far. Next, let me write down dy, where we use the 6, minus 5, and 14. This time we slap it over the y coefficients in the middle. So let me write that down. So I have it written down now. We have 1, 3, 1. That's the original coefficients for x, okay? And then I slap the n numbers, 6, minus 5, and 14, onto the middle row because we're doing y, so we slap it over the y coefficients, which is the 1, 2, 1 now got covered by 6, minus 5, 14. The rest, the z's stay the same, and then right here we have to repeat the first 2 rows. So there's 1, 3, 1, and there's, that's the old one, and 6, minus 5, and 14 is the new one. So having said that, we're going to pull that stunt again. We're going to go down 3 times and multiplying, okay? And that's all added, and then go up 3 times diagonally subtracting. So let's do that. Let's see. Okay, go down. That is 1 minus 5 minus 2. That's positive 10. Plus, next, 6, 1, 1. That's 6. Plus, minus 1, 3, 14. That's negative. Don't forget the negative. Negative 3 times 14, it should be 42. Okay, so that's all the ones going down. Next, minus. All the ones going up has to be minus. Minus first, 1 minus 5 minus 1. That's positive 5. 5. Next, minus. Next, 14, 1, 1. That's 14. Minus. The last one, minus 2, 3, and 6. That is negative something. 8 is 3, 2 times 3 is 6, 36. Minus 36. I mean, sorry, negative 36. We have the minus 30. Minus negative 36. Right? Yes. 36. That equals to negative 9. All right, now let me check to see if I'm right. Let's see, something about, yep, it is minus 9. So if dy is minus 9, then y equals to dy divided by the determinant. So minus 9 divided by minus 3 here, which is just 3, right? It is. That's correct. So we have just one more thing to do, dz, which is the same way. Okay? So let me, again, let me copy this whole thing down. So this time, we're doing the same thing, but we're doing dz. And so the 6 minus 5, 14 now slaps over the last column, okay? I mean the last, yeah, the z position, because we're calculating dz. So it slaps over there, and everything else stays the same. There's 1, 3, 1, and the 1, 2, 3 is over here, which the first 2 rows has to be repeated over here. So I did that, 1, 3, 1, 1 minus 2, 3 is repeated. So that should all look okay. So let's do that thing again. We'll multiply this way diagonally down 3 times, add it, and then subtract it diagonally up 3 times. So let's do that. Okay, so going down, 1 times minus 2 times 14. That's 2 times 14 is negative 28. Plus, next row, 1 times minus 5 times 1. That is just minus 5, right? So negative 5. Yeah, don't forget to push in the negative sign. And last one, 6 times 3 times 3 plus. What is that? That's 9 times 6 is 54. Okay, so far so good. Then minus, going up. Going up, 1 times minus 2 times 6. That's negative 12. Negative 12 minus. Next, 3 times minus 5 times 1, that's negative 15. Negative 15 minus. Next, 14 times 3 times 1, that's positive 42. So 42, okay? And then push the answer, that equals to 6. Okay, so I got dz equal to 6. Is that right? Looks right, yeah. So dz equal to 6, which means z equals to dz divided by d. 6 divided by minus 3, that gives it negative 2. And that is the correct answer. So with that, we have finished example 4. Next, let's look at example 5. Now, example 5 is a short little example that I would like you to do yourself. Okay, the thing is, you notice there's a 3x minus 2y and then 6x minus 4y. Basically, this is twice of that. So then, and then twice of that, but it equals to a different thing. That is, if 3x minus 2y is 4, then 6x minus 4y had better be 8. But it's not, okay? It is, which means there is no solution to this. It's not possible. See, so please look at go through this example yourself. It's similar to what we've done before, except for calculating the determinant, which has being that it's 2 by 2, it has a simple formula that that you need to memorize. Okay, memorize how to do the 2 by 2 determinant. Well, also the 3 by 3 determinant, but we'll worry about that later. So we'll move on to example 6, where we have a 3 by 3 situation. And so what are we going to do? So we have 3 equations, okay, 3 unknowns, and we have to then now find the determinant of that thing. So let me write that down. So I wrote down the coefficients for this particular problem. Okay, there is all the going across is 1 minus 2, sorry, 1, 3, 2 going down, minus 2, 1, minus 4, 3, 2, 3, negative 2, and 6. So I have it got down here, looks okay. And then I repeated the first and the second column. Okay. I repeat it right here, and we're going to do that same trick again. We're going to multiply down, down, down 3 times, add it together, and then subtract it by up, up, up 3 times, and multiply it together. And then we'll add them and multiplied, and then added those 3 things together. So we have 6 things to calculate. So let's do that as we have been doing. And see, that's 116. That is just 1 times 1 times 6 is 6. Plus, next, minus 2, and 2, that's positive 8. Okay, so type in 8. Next, 3 minus 4, that's 9 times negative 4, and that's negative 36. So type in negative 36. So that's what I have so far. Okay, so that's all the going down diagonal. Now we're going to subtract our way up. Minus 2 times 1 times 3, that's 6. Next, minus 4, minus 2, 1, that's positive 8. So minus 8. And lastly, 6 times 3 times minus 2, and I should type in minus 6 times 3 times negative 2. That's 6 times 6, right? 36. So that is negative 36. That's very important. So minus negative 36. See, so I have, it's a minus negative situation here. You can see it better this way. Anyway, so that should be it. So let's press that equal to 0. The determinant of this thing equal to 0. What does that mean? That means that if the determinant is 0, we have to have the determinant on the denominator in order to calculate x and y. So if the determinant is 0, there is no solution, basically. So what happens is that there might be infinite amount of solutions, or that is, the system might be dependent. I can't tell where it's dependent. Yeah, there's see, these 2 equations are dependent. Because let's look at this, okay? Look at the equations more carefully. You notice that equation 1 is coefficients of 1, minus 2, and 3. Equation 2, the coefficients are 2, minus 4, and 6. Basically, equation 1 and equation 3 are the same thing, right? You just multiply that by 2 is all. So being that there is not enough information for just a unique solution, so the answer is there are infinite number of solutions. And the way it's done is, that the book suggests that we multiply equation 1 by minus 2 and then add it to equation 3. Well, which is what I said, okay? Equation 1 and equation 3 are the same thing, which is which is why there is nothing for you to, nothing you can do. You don't have enough equations to solve three unknowns. You need 3 equations to come up with a unique solution. Right now, you basically have only 2 equations but 3 unknowns, so you don't have enough stuff. And yeah, so anyway, that's all we need to know about that. The fact that the planes are intersecting, we don't care about that right now. So I will stop here, okay? And next time, in the next video, I will talk about the properties of determinants.